A warm welcome to everyone. Today is our first session for automotive safety measurement, which is an interdepartment elective, and I welcome everyone on board, and I also thank everyone for choosing this subject. Okay, my name is Harsha. So we'll be going through the we'll be going through the entire topic as well as the syllabus, and we'll be completing the syllabus within the stipulated time. Okay, so this is a 3 hours per week session. That's a 3 credit subject, and it's for 39 hours totally. And the syllabus has also been modified in such a way that it can incorporate it can be incorporated within the 39 hours. Okay, so first we'll be going through what is the textbook which you have to refer, and what are the what is the textbook name, and what is the first chapter. Okay, and I'll be sharing you this textbook as well as the videos whichever the class I have taken. So those videos will also be shared with you in the WhatsApp. Okay, so first is the textbook name is Understanding Automotive Electronics, and it's written by William B. Ribbons. Okay, this is the only textbook which you have to refer for your entire syllabus, and the soft copy will also be provided to you. Okay, so first chapter which we come across in your syllabus is automotive fundamentals, because going through the in-depth of automobiles, first we need to know why the automobile was first developed, or first found out, or first fabricated in a correct way. Okay, so imagine you being in one part of the world and you have to travel to some other part of the world. Okay, and in not now, during the ancient times, the only means of transport was either bullock cart or a horse carriage, so which was doing the job, but again it was taking a lot of time. So to travel, anyone from if he has to travel from Bangalore to Delhi, okay, Bangalore was called as Mysore to Delhi, it used to take weeks together. And if there is any kind of emergency situation, so it would be very difficult for the people to reach the destination on time. So that's the reason people wanted to motorize the carriage actually. So the horse was changed by a motor. Okay, so that is why we call it as, we still measure it as an horsepower. So each horse will have a certain power. So the same thing is dedicated, or it's shown, or is shown for the engines also, engine power also. Okay, so the first one is just the introduction and how the car actually evolved. Okay, so we'll just see a small video now, how the evolution of the car, and the first car which was actually fabricated in the year 1886 by Benz. Okay, a person named Benz. You must be knowing about the Benz car, right? Mercedes Benz. The same person actually fabricated the first car, and we'll see the replica of the car here, and also the evolution of the car from the first car till the latest modern car. Okay,
invented by Carl Benz, patented in 1886. Of course, this is not the real thing. This is a replica.
This is the replica because the first model didn't survive.
To make a video about car safety.
Yeah.
Right? There's not a lot of safety here. Safety would come later. You ready?
Yeah, I trust you.
So as you can see, it is almost like a carriage
I'm
itself.
driving the world's first motor vehicle.
When he made his patent, what did he call this invention?
Patent motor car. This is the gasoline tank. The only place in Germany where you could actually buy Ligroin or gasoline back then were pharmacies. They sold it not as a cough medicine, don't worry. They sold it as a stain remover, a washing agent. In Germany there's still the word Waschbenzin, washing gasoline, but no one really knows why it's called like that. Benz had a really thing for safety. His ignition is a really modern one, because in here there's a battery inside, which was fairly new back then. And of course, igniting the gasoline oxygen fumes with an electric spark is much safer than if you go with your lighter there and you're trying to ignite the whole thing. Let's say the most important part, of course, is the cylinder with the piston, and the piston moves front and back.
This is a
So you can see the piston here, which is still there in the current automobiles also.
And of course, what's really important, it's the oil reservoir. Lubrication is really important, because you can see everything's open here, and so all the time. You lose a lot of oil, and for my colleagues, it's always a big fuss cleaning this thing up. This is the drive belt.
Right.
It's not just a drive belt, it's also your brake. It's leather, so you can imagine if you do brake a lot, you get problems with the leather band. The flywheel here, we need, for the ignition, we needed to start it.
So this is how you started. Nowadays we have a button as well as a key, right? So this is how the first automobile was started.
Okay, see, that's really simple. We don't have a lot of stuff here.
Yeah.
We
there's
just have the
nothing.
steering crank, and this is our gas and our brake.
Okay. You're moving us into gear?
Yeah.
Whoa. This does feel fast.
Oh, it even goes.
Whoa.
Now as you can see that there
The
is
top
no
speed of this
absolute
vehicle
no
was
protection
16
at all.
kilometers per hour.
No
That's about
safety
10
at all.
miles an hour.
We can go fast.
It feels faster than I was expecting.
This is the
Just
Mercedes-Benz
16 years
museum.
later, this car could go 80
See,
kilometers per
First
hour.
one was at
This car
1886,
in
the second
1928
came at
could already go
1902.
192 kilometers per hour. By 1938, cars had gotten incredibly fast. This car right here set a record of 432.7 kilometers per hour. That's almost 270 miles per hour. And another driver trying to beat that record died the same day. And to this day, no one has beat that car on a public road. The automobile revolutionized transportation. It allowed people to travel faster than ever before. But that also created a really difficult physics problem, which is that if you're moving fast and you need to stop or you hit something, you have to decelerate incredibly rapidly, and that creates huge forces on the people inside the car and causing injury and sometimes death. And as more and more cars came on the road and traveled faster and faster, the number of fatalities increased, peaking in a lot of developed nations in the 70s. But then scientists and engineers embraced this challenge and figured out new innovative ways to create cars to minimize those injuries. To improve safety, regular crash testing began in the late 1950s. But what amazes me is the crash test dummy hadn't really been perfected yet. So actual scientists and engineers drove the cars in crash tests.
People like me actually started to do first testing with themselves. Certain accelerations, how much you can suffer, before you get any injuries. Of course, today this would be impossible to do.
Well, when they finally did develop crash test dummies, well, then people weren't driving the cars anymore, so they needed a different way to propel the vehicle. And so they used this, a hot water rocket, to propel the car into all sorts of crash test situations. One of the
Even
first
now the crash
major
test is
safety
done for
innovations
each and
that was
every model
introduced in a
which
car
comes
like
out of
this
the
in
factory
1959
and before
was
getting
crumple
approval.
zones. That is, regions in the front and the rear of the car that were designed to collapse in the event of an accident. I remember when I was a kid hearing about crumple zones thinking that that was a ridiculous idea to improve safety. Why would you want your car to collapse? But the point is to increase the distance over which the deceleration occurs. And in doing so, you actually reduce the magnitude of the acceleration, and so you reduce the forces on the passengers inside. And that is what saves lives.
This vehicle has done a 64 km/h crash, frontal impact, against a deformable barrier. This is what we classically call the crumple zone.
But it's this beam here that's designed to crumple?
Exactly. So this takes away a lot of energy by crumpling. The passenger compartment itself is designed with different steel qualities, if you want, high strength and ultra high strength materials, so that it's getting stiffer and stiffer as closer as you get to the passenger compartment.
One of the biggest challenges for car safety is Newton's first law that says whatever is moving at a constant speed will tend to maintain that constant speed. So if a car hits something, the people inside maintain their constant speed, fly through the windshield, and suffer a very high deceleration when they hit the road. This is why seatbelts are so important. They ensure that you stay in the vehicle and decelerate with it. When seatbelts were originally introduced, they were an option, something you could pay extra for. But once we realized just how useful they are and how they save lives, well, they became standard, and now they are mandatory. Now, airbags were made available by Mercedes-Benz for the first time in a series production car in 1981. And again, the idea is similar. In a head-on collision, you want to stop the driver's head from accelerating too fast into the steering wheel. And that's what the airbag does. It allows that acceleration to take place over a larger distance and therefore at a lower rate. So it helps preserve the driver's head.
What you can also see is, look at this tiny gap here. You can barely get your fingers in between.
So that steering column has collapsed.
Exactly, and it has collapsed in a designed way. So after you reach a certain force threshold, then the driver basically pushes away the entire steering column, including the airbag, by taking away energy. And what you want to do as an engineer for restraint systems is that you want to basically connect the driver, passenger, and the occupants as tightly as possible to the car in a way that you have the most time to decelerate.
Seat belts, crumple zones, and airbags are all passive safety features. They're passive in that they assume a collision is occurring and they're just trying to reduce.
So as you can see, in the earlier days when the car was actually fabricated, there was no safety features at all in 1886. Okay, so later on in 1902, when the next car was made with had at least the doors as well as the engine cover. Okay, so that's where the safety concerns started in the automobile, started getting incorporated in the automobile. Okay, so your subject is totally named as automotive safety measurements. So we will be seeing what are the safety measurements which was there and how the automobile actually worked. Okay, the first and foremost safety feature which was available was your crumple zone. As you saw in the video, there was a pocket which was made in the engine bay. So as soon as you hit a collision, that used to crumple. So when that used to crumple, it used to reduce the force. Okay, so that is how. The second one was your seat belts. Seat belts was made mandatory way back in 1940s. Okay, 1930s actually. Okay, so those things were the first safety measurement, and that is how the first vehicle actually evolved. That's not the normal vehicle, but that's a gasoline vehicle. Now we'll just see a small glimpse of a 1770 vehicle wherein it was actually a steam based vehicle. Okay, so this is actually the first vehicle which was actually made in 1770, and it was made by a French inventor, and it didn't run on a gasoline, okay, like petrol or fuel or anything. It ran on the coal. So as you can see, whether to start it and to stop it also, it used to take a lot of time. So it almost took 1 century for the inventors to come from to shift from the coal to the normal fuel. We'll just fast forward it once. And it's still working. This is the working model. It is still working. And it was pretty dangerous also. Okay, and now let's pause this and let's come back to the next topic. So I hope everyone are clear what is the evolution of an automobile and what are the safety features which was there in the beginning where an automobile was fabricated. Okay, two major players were there. One is Benz and one was Ford. So which the cars even now they are in production. Okay, now use of electronics in the automobile. As you can see in the first car, to start the engine we had to actually rev it up. Revving it up is nothing but we had to make a motion of the entire piston. Okay, so which was again time consuming, and it was a long process. So to overcome this, what the inventor did is they started installing a igniter. Okay, so rather than making one rotation of the piston, the motor was fitted. So that as soon as the key is pressed or the key was turned, the motor actually turned the piston one round and the vehicle was started. So this is where the electronics was started getting more and more incorporated in an automobile. And after that, it is just the history, wherein the next was your ACs, air condition blowers, your radios, okay, and your all sorts of gauges, fuel gauge, speedometer gauge, even the airbags also. Everything electronic was controlled. Okay, there is something known as ECM in your vehicles, in your car. So that is like the brain, that's like the processor of your car. So all the all the electronic components, everything is connected to that ECM only, and everything will be controlled through ECM at all. Okay, so now we'll see the evolution of automobile electronics. So as I said, electronic engine control for minimizing exhaust emission and maximizing fuel economy, instrumentation for measuring vehicle performance parameters and for diagnosis of onboard systems malfunction, driveline control, vehicle motion control, safety and entertainment or navigation control. So all these things employed electronics in that. Okay, next, so we will see what is the chapter overview. So that is the physical general automobile physical configuration. So now an automobile consists of all these components, which is very important even for your exam point of view. It is very important. Okay, so these things, so all these things we'll be studying in your entire syllabus. First is the engine, which is the heart of the vehicle. Without engine, the vehicle will not start and will not move. Next is the drivetrain. So whatever the power is generated from the engine, it has to be transferred to the wheels. So that job is done by the transmission or the drivetrain. Next, when you're traveling, you need to have a smooth ride. You need not have to have a bumpy ride. So to avoid all the bumps on the road, suspension is used. Next is the steering column or the steering system, wherein you have to steer the vehicle whichever position you want. So that is by steering. Next is the very important part of the vehicle, that is the brakes. So as you saw, when you're moving fast, you need to stop the vehicle also for safety as well as to avoid the collision. So brakes are very much important, and brakes. Next is the instrumentation panel, where you will be seeing all the gauges. Next is electrical and electronic components. Next, motion control, safety. Safety includes your seat belt, warning, your airbags, and even collision avoidance, radar system, and all the other things. Next, comfort or convenience, and entertainment, communication, navigation systems. Okay, so all these things actually have evolved over the time. All these things have evolved over the time. Okay, so how does an actual vehicle look? And this diagram is very important. They will ask it for 10 marks. Okay, so what is the actual system configuration? What all does a vehicle or a car consists of? Okay, so the first one is the chassis. So as you can see, this line over here, can you see this line? This line. So this is a chassis. Okay, so chassis is nothing but a platform wherein you will start accumulating, or you will start installing other components. So there are different kinds of frames or chassis also, ladder based chassis and omega arc chassis. So many different types of chassis are there, but for simple understanding, it is just a ladder based chassis. Why it is called ladder based? If you can see, a ladder will be like this. Here 1, 2 and 3. Okay, so here there will be the engine. Here on this part there will be the differential or the drivetrain, and this will be the compel zone for front and the back, where the body will sit. Okay, so you can see this 1, 2, 3 and 4. Okay, 1 second, let me erase this off so that you can see the Okay, so first is the chassis. Second one is the main part, that is the engine. Next is the drivetrain. So this is the drivetrain. This one is the drivetrain, where the power of the engine is transferred to the wheels. Next is the suspension system, where you cannot see it here clearly, but in the next topic you will be studying about suspension. Next is also the brakes, and the entire body itself. That is called as the cabin, or a cabin, or the place where the actual passenger will be seated. Okay, so this is the physical configuration of the car, which is very much important. So I'll be going through what is differential drive shaft, what is the drive train or the differential, how it works. And there are two types of engines, two types of transmission also. One is automatic transmission and one is manual transmission. How it works, we'll go through it. It is there in your syllabus. And regarding the brakes also, there are two types of brakes, that's the disc brake and the drum brake, and how both of the brakes work actually we'll be going through it. And suspension, there are different kinds of suspension nowadays, but in the earlier time there was only either a shock absorber or shock absorber with a spring, or something known as leaf suspension. Okay, so now it has been evolved to electronic suspension, independent electronic suspension, and various other types. So we'll be going through all these things. Okay, so next topic will be the engine. So this is how the engine actually looks like. So the engine, you can see this here. This is the whole part of the whole engine. I'll just zoom it a little. Which you need not have to draw, don't worry about it. It's only for your understanding. So the main parts of the engine is, first is the piston rods. These are the pistons, 1, 2, 3. Okay, depending on number of pistons, the entire engine is called as either 3-cylinder piston, 3-cylinder engine, 4-cylinder engine, 6-cylinder or 8-cylinder. Even 12-cylinder engines are also there. So most of the cars nowadays which you are driving is either 3-cylinder engine or a 4-cylinder engine. Okay, and this one is a petrol engine. How we can say whether it is a petrol engine or not? Because there are spark plugs in it. Okay, so there are two types of fuel which can be added to the, or which can be used in the engine, and two different types of engines are also there. One is petrol engine, one more is diesel engine, and nowadays the new engine is the electronic engine, where for your electronic cars. Okay, electric cars. So you can see this, there are near the piston here there is something known as spark plug. So that spark plug also we'll be studying how the spark plug works, and the spark which is provided to it is called as the distributor. See, these are the spark plugs here. So this is the distributor which distributes the spark evenly for all the cylinders. Distributor. Okay, so these are the rocker arms, and the most important thing is camshaft. So this is the camshaft, this is the crankshaft. Crankshaft is used to crank the engine, camshaft is used to deliver the power from the piston to the drivetrain. And this is then air filter or an air intake, because for combustion to happen inside an engine, oxygen is very much needed, and not any kind of oxygen, but it has to be a pure oxygen. Only then the combustion between the fuel as well as the air will happen properly. So for that there will be an air filter here which will filter the air, and the pure air as much as possible without any debris or any sand particles will be provided to the engine, so that the blast process can happen. Okay, so these are the cooling fans. So whenever there is a blast process, or whenever there is a combustion either in the petrol engine or a diesel engine, or in fact in your electric cars also, there is a cooling fan, and also there are radiators also. Okay, so you will be studying about crankshaft, camshaft, pistons and cylinders, and also the spark plug, distributors in your next chapters. Okay, now first one will be just I'll just stop it over here. I'll just give you the basic blocks of your entire vehicle. So the major components of the engine includes, first is the engine block itself, next is the cylinder which I have already informed you, next is the crankshaft, next is the piston, the connecting rods, camshaft, cylinder head, valves, fuel control system, ignition system, exhaust system, cooling system and electrical system. So these are the 13 major components of the engine. Next is the engine block. So in the engine block we will be having the 4-stroke cycle. So this 4-stroke cycle, I am sure that you guys have already studied in your first basic mechanical subject, I guess, but still we'll go through this in the next class. I hope you have understood the basic concepts. So before I end the class, I'll just go through one more video, that is the evolution of cars from this, that is the first car, to this is the Tesla electric car. So we'll just go through this once and we'll end the class. So this was the first car in 1886. That is a gasoline car, to be very precise. So this was actually the gasoline car which was found out by Benz. And after 1886, in 1900, this was the car which actually came into production and which was on sale also for commoners. In 1910. So here, as you can see, there was no windshield or there was no headlight in their previous vehicles. So here in the evolution, you can see the headlight, and this is where you start. This is how you start the engine. In 1920, every 10 years. So this is, you can see there is a top, there is a windshield, there are lights, okay, and there is basic comforts also. And there's a spare tire also. Next in 1930, that's after 10 years. You can see a hard top. You had basic amenities like your AC, your seat belt, everything by 1930. .1940. So this is much of like a family car. Everything was inside these bonnets, and as also you can see the rear spare tire was placed in the trunk or your dicky. And from 1950 onwards, there were cars where racing was happening, as was also the more and more modern or modified version of the vehicle was evolved. In 1960, airbags was also introduced in 1960. But in India, we are only seeing airbags these days within last 5 years span. But in Western countries from 1960 only, airbag as well as your seat belt is mandatory. As you can see, this is a racing car in 1970 with fully automatic and fully equipped vehicle. In the 80s, Audi. More and more refinement you can see, as and when the evolution happens, more and more refinements you can see, and more technologies was also involved in it. So these are the headlamps which will actually go inside. As soon as you turn on the headlamp, these headlamps actually pop out. And these are the 2 doors and V8 engine. That means to say it has 8 cylinders. Like how you saw 3-cylinder picture, like that 8 cylinders will be there. And these are the vans which we have now. This is for carrying more people. These automobiles were introduced. And the best thing about Honda is they have paddle shifters, as you have seen in movies, where the gear will be below the steering column itself. In 2005, you can see the racing cars. Let's see what is there. And this is Bugatti Veyron, which is one of the fastest passenger car which is available in the world. It has 2 engines, one in front and one in the trunk. In 2015, we started adding little bit of trendiness to it, and more safety was the major concern. As you can see, the disc brakes here. This is a Ferrari model. Ferraris are almost all the vehicles are rear engine, The engine will not be in the front, the engine will be at the back. So that is why, to cool the engine, see, these are the air ducts. Again, one of the fastest, that's the Bugatti Veyron. In 2020 we have an all modern Tesla car, and this is completely electric vehicle, and it has autopilot, wherein you can just type in the destination and automatically you need not have to even sit in the driver's seat. So it will automatically take you to the destination wherever you have entered the destination. And that's actually in production also, the Tesla vehicles, and we'll see about that particular engine also, how the electric engine works actually in your future classes. Okay, first in your next class we'll see just the 4-stroke basic SI engine. Okay, so we'll see this, and later on we'll go with the different kinds of engines. Okay, thank you so much. Any doubts are there, please you can ask me now, or you can also message me, and I'll just clear your doubts. Thank you so much for your time. Stay safe.